factor posited by immediate sense awareness. Recognition takes place within the present without any intervention of pure memory. For the present, fact is a duration with its antecedent and consequent durations which are parts of itself. The discrimination in sense awareness of a finite event with its quality of passage is also accompanied by the discrimination of other factors of nature which do not share in the passage of events. Whatever passes is an event. But we find entities in nature which do not pass. Namely, we recognize samenesses in nature. Recognition is not primarily an intellectual act of comparison. It is in its essence merely sense awareness in its capacity of positing before us factors in nature which do not pass. For example, green is perceived as situated in a certain finite event within the present duration. This green preserves its self-identity throughout, whereas the event passes and thereby obtains the property of breaking into parts. The green patch has parts, but in talking of the green patch, we are speaking of the event in its sole capacity of being for us the situation of green. The green itself is numerically one self-identical entity without parts, because it is without passage. Factors in nature which are without passage will be called objects. There are radically different kinds of objects which will be considered in the succeeding lecture. Recognition is reflected into the intellect as comparison. The recognized objects of one event are compared with the recognized objects of another event. The comparison may be between two events in the present, or it may be between two events of which one is posited by memory awareness and the other by immediate sense awareness. But it is not the events which are compared, for each event is essentially unique and incomparable. What are compared are the objects and relations of objects situated in events. The event considered as a relation between objects has lost its passage and in this aspect is itself an object. This object is not the event but only an intellectual abstraction. The same object can be situated in many events, and in this sense even the whole event viewed as an object can recur, though not the very event itself with its passage and its relations to other events. Objects which are not posited by sense awareness may be known to the intellect. For example, relations between objects and relations between relations may be factors in nature not disclosed in sense awareness but known by logical inference as necessarily in being. Thus objects for our knowledge may be merely logical abstractions. For example, a complete event is never disclosed in sense awareness, and thus the object which is the sum total of objects situated in an event as thus interrelated is a mere abstract concept. Again, a right angle is a perceived object which can be situated in many events. But though rectangularity is posited by sense awareness, the majority of geometrical relations are not so posited. Also, rectangularity is in fact often not perceived when it can be proved to have been there for perception. Thus an object is often known merely as an abstract relation, not directly posited in sense awareness, although it is there in nature. The identity of quality between congruent segments is generally of this character. In certain special cases this identity of quality can be directly perceived, but in general it is inferred by a process of measurement depending on our distinct sense awareness of selected cases and a logical inference from the transitive character of congruence. Congruence depends on motion, and thereby is generated the connection between spatial congruence and temporal congruence. Motion along a straight line has a symmetry round that line. This symmetry is expressed by the symmetrical geometrical relations of the line to the family of planes normal to it. Also, another symmetry in the theory of motion arises from the fact that rest in the points of beta corresponds to uniform motion along a definite family of parallel straight lines in the space of alpha. We must note the three characteristics: 1. Of the uniformity of the motion corresponding to any point of beta along its correlated straight line in alpha, and 2. Of the equality in magnitude of the velocities along the various lines of alpha correlated to rest in the various points of beta, and 3. Of the parallelism of the lines of this family. We are now in possession of a theory of parallels, and a theory of perpendiculars, and a theory of motion, and from these theories the theory of congruence can be constructed. It will be remembered that a family of parallel levels in any moment is the family of levels in which that moment is intersected by the family of moments of some other time system. Also, a family of parallel moments is the family of moments of some one time system. Thus we can enlarge our concept of a family of parallel levels so as to include levels in different moments of one time system. With this enlarged concept, we say that a complete family of parallel levels in a time system alpha is the complete family of levels in which the moments of alpha intersect the moments of beta. This complete family of parallel levels is also evidently a family lying in the moments of the time system beta. By introducing a third system, gamma, parallel rects are obtained. Also, all the points of any one time system form a family of parallel point tracks. Thus there are three types of parallelograms in the four-dimensional manifold of event particles. In parallelograms of the first type, the two pairs of parallel sides are both of them pairs of rects. In parallelograms of the second type, one pair of parallel sides is a pair of rects, and the other pair is a pair of point tracks. In parallelograms of the third type, the two pairs of parallel sides are both of them pairs of point tracks. The first axiom of congruence is that the opposite sides of any parallelogram are congruent. This axiom enables us to compare the lengths of any two segments either respectively on parallel rects or on the same rect. Also it enables us to compare the lengths of any two segments either respectively on parallel point tracks or on the same point track. It follows from this axiom that two objects at rest in any two points of a time system beta are moving with equal velocities in any other time system alpha along parallel lines. Thus we can speak of the velocity in alpha due to the time system beta without specifying any particular point in beta. The axiom also enables us to measure time in any time system, but does not enable us to compare times in different time systems. The second axiom of congruence concerns parallelograms on congruent bases and between the same parallels which have also their other pairs of sides parallel. The axiom asserts that the rect joining the two event particles of intersection of the diagonals is parallel to the rect on which the bases lie. By the aid of this axiom, it easily follows that the diagonals of a parallelogram bisect each other. Congruence is extended in any space beyond parallel rects to all rects by two axioms depending on perpendicularity. The first of these axioms, which is the third axiom of congruence, is that if ABC is a triangle of rects in any moment and D is the middle event particle of the base BC, then the level through D perpendicular to BC contains A when and only when AB is congruent to AC. This axiom evidently expresses the symmetry of perpendicularity and is the essence of the famous pons asinorum expressed as an axiom.